Okay, Bismillah. Okay, folks, welcome back. We're looking at circle theorem examination style questions. Question number 7. We left off last week at question number 6. So, without any further delay, let's get started with these questions. Now, we need to start filling in the angles on this particular shape. So, first of all, we come along here. Okay, I think it's best if we use possibly the highlighter. Okay, so come along this line here, the tangent. Come along the chord over here. And we go along here. Oh, oops. And then we flick it down here. So I call this as the nickname that I call it is called the Z flick. Or was actually called the angle between tangent and a chord is the opposite segment theorem. So if this here is 58 over here, then we know for sure that this angle here will also be 58. So we can put the 58 in here first of all over here. So we start filling in the angles. And we actually need to calculate the size of angle OAB. So OAB is, so the angle that they want us to find out in the question is this angle here. So that's the angle we've got to work out finally. But we need to start filling in the information that we know on there. So this is your homework question. Have you done it for homework? Okay, so pay attention to what we're doing right now. If you've done it for homework, correct it. Okay, if you haven't done it for homework, fill it in now as though you're doing it, yeah? So you see how we do it. So that's 58, because this one's 58, this one will be 58. Now we've got to give a reason for that. So let's write that reason down. I'm going to use any available space I have to me. Let's have a look what we write down for on there. Okay. So we say angle. Okay, how do we define this angle over here? What do we call the angle? We call the angle CBA or ABC. It doesn't really matter how we label that one. So angle A is the angle in the middle. Angle ABC. Oops, I meant to write a little triangle there. Okay. We'll actually leave that part out actually. That's better. So angle ABC is equal to 58 degrees. So I've put that 58 degrees in there. I know why it's 58, but now I need to explain it to the examiner how that is 58. Because what's the reason? What do we say? We say alternate segment is an alternate segment to which angle? This angle. This angle is defined by CAS. Okay, can we see that all clearly? CAS there? So that is the reason why that is 58. Now let's start filling in other parts of the triangle. Let's change. Okay. Now we've done the alternate segment there. Okay, I'm going to rub off the highlighted part now because we don't need that for the moment. So I'm going to rub off this highlight. Okay, rub off this highlight here. Okay. And we do still want to find out this angle here. That's the angle that we need to eventually work out. Okay, now, what else do we know? We know that this triangle here is a special type of triangle. This triangle is called an... Sorry about that, I just funny. Oh gosh, this is supposed to be a straight line, folks. Sorry about the wobbly bit there. Now, what do these lines here tell us? That this triangle is an isosceles triangle. If it is an isosceles triangle, then we can quite easily work out what this angle here is and what this angle here is. Can't we? Okay, so what do we do for that? What can we say? So the next part of the maths, what we're going to say. So we can work out that 180 degrees. If we minus, what do we minus? 58 degrees. Okay. And after we minus the 58 degrees, we then divide the answer by 2. And that will give us an answer of what? Anybody any ideas? 180 minus 58 degrees divided by 2. Okay, 180 minus 58. So the final answer is, thank you. Somebody's worked it out. 61 degrees is correct. So this angle here is 61. This blue angle here is also, it's not the angle that we're looking for at the moment, but this blue angle is 61 as well. Now, if that's 61, what is this angle here going to be? The angle there is also 61. Why is it 61? Because of another Z over here. Okay, remember that? The Z. So this angle and this angle are the ones which are alternate segment. So these two are alternate segment to each other. So that's 61 as well. So we've got all those angles in there now. What we need to work out is, we still got to work out that little bit there. So, what do we do next, folks? What do we know? We also know, okay, let's use a different color for the highlight so we can stand that clearly. I'm trying my best to make a straight line here. Okay, this line here is what do we call this line? I can't draw a straight line. It's just, okay, it is just so. Okay, can somebody pass me a ruler? I use on the vacuum pan. Pass me a ruler. Alright, we need to get around this one. This is just not very good. Okay, let's just. I don't think we should use that now.
So isn't that a right angle then?
Hang on there. This line and this line gives us what angle?
Right angle.
A right angle. Why is it right angle? Give me the rule for it.
Because the angle between a tangent and a radius is a right angle.
Beautiful. So we need to write that down. So we say the angle between a tangent now where's my tangent? My tangent is TA. So T to A or even TS between a tangent and, so I'm being very specific, and a radius. And what is the radius? The radius is OA, because O is the origin of the circle. Is always oops, 90 degrees. So we know this angle here is 90, and we know this one here is 61. So we can work out our missing angle. Our missing angle is this angle here between these two, which is a bit difficult to draw at the moment. Okay, now, so we can work out the angle by doing what? We can do 90 minus the 61 will give us our missing angle. Our missing angle is called OAB. Angle OAB. Which is equal to, what's that equal to then? 29 degrees. So these are the explanations that we need alongside with the mathematics that we come out with. We need to mention alternate segment. We need to mention that it's a, did we mention earlier that's isosceles triangle? We haven't. We missed that little bit out. Let's put that in right now, folks, before we forget. So we say here, isosceles isosceles triangle ABC. So because of that, that is the reason behind the black bit of mathematics over here, the black part here. Okay? Are we happy with that? So every single thing we've done, we've justified it mathematically. This is this because of this. This is this because of this. And that's what the examiner is looking for. And we've got to use the right language, alternate segment theory, isosceles triangles, angle between tangents. We have to mention the actual maths that we're learning, memorizing. Are we happy with that, folks? Yeah? Are you happy with the language that we're using? Good? Okay, question number 7. Is there any more to do with question number 7? Do we have finished question number 7? Yes. Lovely. Okay, here comes question number 8 now. Okay, let's move on to question number 8. Let's clear the page. Let's move forward. Question number 8. Now, question number 8 had been passed 2 parts. Question number 8, which will fit then. Here we go. Okay, Bismillah. Right, let's have a look at question number 8. What have we got? We got a hand. Not in the hand, we need a pen. Right, A, B, C, and D are points on the circumference of a circle. Angle ABD is 54. We can see that, and that's 28. Find size of angle ACD. So ACD is A to C to D is the middle one. So we need to work out this angle here. That is our angle that we need to work out. And that is quite easy answer. And the answer for that one is?
I will study on the stage of.
Okay, so the reason, you actually give me the reason for one, angles, subtended. Yeah, so angles, subtended. So we've got to use the correct mathematical terminology which we learned in the lesson. Angle subtended. I don't know why it's so blocky for when I'm recording for some reason. Subtended by an arc. Okay, so here's our arc here. From here to here is our arc. Okay, angle subtended by. I'm not too happy with this blocky handwriting. And an arc. Okay, I'm going to use text style. Blue. Okay. I'll start writing now. Angle subtended by an arc in the same segment of a circle are equal. That's one of the nicest and easiest questions I can give you. You know straight away that's 54. Done. Okay, and that's the mathematical reason for it. Got rid of that. So we've got a bit of handwriting on there and a bit of typed text, so that's nice and clear. So angles subtended by an arc in the same segment of a circle are equal. That's what the examiner wants to see for you to get your mark. Are we happy with that question? Yes? How long have we move on? Is there any more part of that question? Is that it? That's it. Let's move on then. Okay, let's go. Sorry, let's go to this text mode. Go to bounce mode. Okay. Okay, question number 9. Right, what can we say about question number 9? It says we have WX is the diameter. That's very important piece of information that WX is the diameter. Can you tell otherwise that it's the diameter? As by look at the diagram. Can you tell it's the diameter? It looks like the diameter, but can you be sure it's the diameter? Unless they tell you. Because normally they put little dots in there, and with the OBs, then you know it's the diameter. But here, that first line is very important. Do not miss that first line. WX is the diameter of a circle. Y is the point on the circle. Z is the point inside such that. So now you've got an isosceles triangle over there. So, and these are parallel lines indicated by these arrows over here. Find the size of angle XZY. So where's XZY? XZY is this angle over here. Okay. That is the angle that we're trying to work out.
There's no right angle there.
Yeah, that's right. Why is the right angle there? This is a right angle because angle in a semicircle is 90. That's the rule that we learned. Okay, so we can fill that in. Okay. So the first thing we can say here is, we can make it a statement is angle. Okay, what angle are we talking? We're talking about angle WYX or XYW, whichever you want. XYW, which is this one here, is equal to 90 degrees. Y is equal to 90 degrees because we say the angle in a semicircle is a right angle. And that is the rule. And that's why it's 90. So angle. Okay. Okay, angle in a semicircle. Okay. And that will do for that. And that's the reason. Okay, what else do we know? If that's 90 up there, can you find any other 90s?
They're x's.
That's right. That's also 90. And why would that be 90? So let's give a reason for that. So we can now say angle. Okay, we got y, x, y, z. No, it's got to be y, x, z. Okay, so angle y, x, z is equal to 90. Okay, why is that 90? Because parallel lines Okay, now you've got parallel lines there. If you've got a straight line going across 90 degrees, they have to meet at 90, isn't it? So that's the explanation for that. That part is, so we've done those two bits. Now, if you know that's 90, what else do we know? Let's go to a black color now. Black. Now, what do we know about this triangle here? So if you were to consider this triangle here, tell me what kind of triangle this is. What name do you give it? It is an isosceles triangle, isn't it? Yeah? So we can now say the angle. Okay, if you want to work at angle XZY, so angle XZY is equal to 180 degrees minus the 90 and then divided by 2. Okay, which gives us an answer of. So we've given the answer now. Now we've got to give the explanation. So let's quickly switch to text. Okay, so what we're going to say there? We're going to say isosceles triangle. Angles okay, so it's an isosceles triangle, the angle added 180 degrees. That's our statement. That goes. So we have here, if you look at the board here, we have an angle, explanation, an angle, explanation, an angle calculation, and its explanation. So for each part of the work, you've explained it mathematically. Small, have you got those bits of explanation done already? You haven't done for homework? Like that? Okay, you put them in now? Okay, when you put things in now, let's try to do it in a different color, so we can see the difference between your homework and then your classwork. I'll be happy with that, folks. Okay, right. We've done the answer completely. 3 bits of mathematical statements. So we've given the answers and explained it.
So the answer's 45.
Answers 45. Finished. That one's done. Okay, let's clear the page. And let's get in back to mass mode. And I think we're coming towards the end of the paper now.
One more question left.
One more after this one, yeah? Okay, that's lovely. Alright, that's good. Right, okay, so the ABCD is a cyclic quadrilateral. That's keyword, cyclic quadrilateral. Then we got rule number 4. The opposite angles of a cyclic quadrilateral add up to 180 degrees. So where is our cyclic quadrilateral? Here, what's this? What's the hand? From A to B to C to D. Goes around in like that. Oops. Okay, right. So we got tangent here as well. And they want us to work out Work out the size of angle AED marked X on the diagram, which is here. So they want us to work out this angle here. That's angle AED. Okay, you must show your working. Give reasons for any angles you work out. Okay, let's start putting in information that we know from what they've given us. Okay, now. Okay, what can we tell straight away in the beginning? So we got 40, 32. What else can we fill in? If this is a 32 over here, is there another 32 in the diagram? Can anybody see another 32 in the diagram?
No.
Yeah, next to 40.
Next to the 40. So this is going to be the same as that. So if this is 32, this is also 32. So now we're going to state it's 32, and we need to, what else? If this is 40 over here, is there another one? Is there another 40 on there?
D. D.
That one here.
Yeah, that one.
So that one's also 40. Lovely. Good. Okay, that's nice. Okay, what else do we know? Okay. Okay, so we got that's 32 because that matches that one, that's 40 because that matches that one. What else do we know?
D. 40.
Okay. Now, if you know this angle here and that angle there, do we know this angle? By any chance? All that give you? So that's 40, that's 32.
Take away from 180.
That's right. So that's 40 over here. That's 32 over here.
108 degrees.
That'll give you what?
108 degrees.
108 degrees. That one. That's 108. If that one's 108, what will this one be? 72, isn't it? Because angles at a point on a straight line to 180, is that right? That's 72. So we're slowly moving ourselves around the shape. Okay, right. Lovely. Now, okay, let's see if we can see one of the rules here. Remember our Z flick? Okay, here's the flick. I'm working backwards from the flick part to here. Oh, let's try and get this on the line. No, I'm struggling today. Okay, right. Can we see our Z flick now?
Yeah.
Can you see this angle here, in this corner here, should be same as that one there. So we can now, quite confidently, if we can actually manage to draw it in, we can say this angle here is 40 degrees. Why is this angle here 40 degrees? Because we are using alternate segment, is that right? So let's make that statement. So we can say angle DAE is equal to 40 degrees. That's the one we need to use. We need to use that 40 degrees angle. It's equal to 40 degrees. Okay, now what is the reason for that? So let's go to text mode. Okay, right. So what do we say? What is the nice way of saying that? We say alternate segment. What do we say? We say the angle between a tangent and a chord equals the angle in the opposite segment. Or we could say angles alternate segment to angle ABD. So let's label that one then. So we can say angle, okay, angle ABD, angle ABD is alternate, okay, one second, okay, we've got to make sure we get this with angle segment to ABD. Angle ABD is in alternate segment. Okay, now I think I'm gonna change my wordings a bit. We need to put here angle DAE. This one here, just give me one moment. segment to angle ABD. Okay, so what we're saying here is this angle that we have here, this angle here is an alternate segment to that one. And that will do for the explanation of where that comes 40. Now, what is x going to be now? According to the calculation that we have here, what is x going to be? So x is equal to what?
180 minus 72 minus 40.
That's right. But before we go, how do we get to all these? Where did the 108 come from? So we said that was 40, wasn't it? Yeah. So how is that one 40? Because that one's 40, that made that one 108, that made that one into 72, isn't it? Yeah, remember, this 72 came from this one to that one, isn't it? Yeah, so we can't, so we can say this angle here, so let's work that out. Let's change color. Okay, now we need to say angle, what was it? Angle BCD, angle ACD, okay, is equal to 40. Okay, and the reason for that is going to be, what's the reason for that? For that we're going to say angles okay, wrong color. That's better. Angles which are standing on the same arc are equal. Okay, so we explained that one. We explained that 40. We know that's already 32. Have you explained the 32? And that was already there, wasn't it? Yeah, that's already there. Sorry. Now, where does the 108 one come from? So the 108 angle.
108.
Yeah, how do we get the 108? So we can say angle was the CDA. CDA is equal to 108 degrees. Okay, it's equal to 108 degrees because of what reason? Abdullah, can you give me a reason, please? Okay, because triangle ACD has to add up to 108. That's it. Okay, so we say triangle ACD.
So what was the top one again? ACD equals 108.
We said triangle CDA is equal to 108.
Okay.
And now we give the reason. So triangle ACD has an angle sum of 180. And that explains why we got that angle from 180. Okay, so we need to write down here a little bit of extra calculation here. What calculation did we do? We done here 180 degrees minus 32 minus 40. Give you that one. Okay, and that's the reason why. Lovely, beautiful. Okay, now, so we explained where that 40 came from. We explained where that 40, the 108 came from. Now we need to get this angle over here. This angle here is going to be 72. Okay, we could have also done this. This is 72, that's 108. Why those 108?
Well, that X.
Okay, we missed out one easier way of doing it. So we've done this way here. Okay, that's fine. I'll put that in brackets. Now let's look at this over here. If I look at this part here and I highlight it in pink. If you look at this angle here, what was this angle altogether? This angle is 72, isn't it?
Yeah.
So what should this angle here be? Should it be, because it's the opposite end of a cyclic quadrilateral, so what should that be? 108. But that has 70 all that. So that would be like a quicker way of saying it. Yeah, so that angle there is 108 because that's 72. And these two are opposite each other.
So what about x? You're gonna leave x
Sir,
on
you
top.
got a question wrong name, sir.
What's that?
They say
Okay, right, let's just carry on from where we are at the moment. We've got to now work out the 72 angle. Okay, let's go to a red. So we say angle ADE is equal to 72. Why is it equal to 72? Somebody give me a reason why it's equal to 72. So we say angles at a point on a straight line add up 280 degrees. We can't fit any more than that. Okay, last but not least, so angle AED is equal to 68 degrees, which is equal to x. Why is that? Because it's 180 degrees minus 72 minus 40. Okay, and the reason for that is nice and straightforward. So that gives you 180.
So the answer is 68 degrees.
68 degrees, that's right. Okay, right. I have spotted a quicker way of doing that question, as Mr. Harun said. There's got to be a quicker way. There is a quicker way. I'm just going to now quickly go over that quicker way, which will take us 2 more minutes. And that will take us from here. Okay, so we'll be able to go from this level here, from where we go up to these two, and go straight towards the answer. Let's do that on this side over here. Quick way of doing it. So we've done all this over here. That is, I would say, the more the scenic route. It is mathematically correct route, but we've got a much shorter method, and we're going to do that right now over here. So let's have a look. I'm going to do some rubbing off of the highlights on the. Okay. So the rubber. We know that's 40. I'm going to rub this off here, all of this. Okay, I'm going to rub off, okay, that. A bit of the color. Okay, and I'm going to do a new highlight. Okay, now let's look at this triangle here. Triangle. Why is it so difficult to draw a straight line on this vacuum pad? It's so difficult. Okay. Okay, can we see that triangle there?
Yeah.
Okay, it's just now we can say now. Okay, angle. So what's the angle x going to be? X is going to be equal to 180 degrees. Looking at that highlighted triangle, minus 40, minus 32, minus another 40. Is that right? So this angle here is 180. Take away this angle and take away, because we know this corner. We know this corner and we know that corner. So what's x take away all of that? 68.
So you should.
So there you go. So this is the Harun technique of the non-scenic route. And the answer for that is angles in a triangle
No, sir.
add up to 180 degrees. So as we can see here, this is the non-scenic route, very quick one. It all depends on what you spot in the examination. Do you understand what I'm saying? You might say, okay, I knew that one, then I worked out that one. So that might be the route that you take. So that's not a wrong method, it's just a slightly longer method. This is the much quicker direct method. It's all about what you see in the question. Both methods really lead to the same answer. As long as you explain your method, they are both as good as each other. But I would rather go for the non-scenic route if you can spot that in examination, because that will save you time. What is number supposed to be there? It's supposed to be 40. Okay, I'll be happy to go on. Okay. So write down the size of angle XWZ. So XWZ, where's that? So XWZ, which is here. We know that this angle is half of, what is it going to be? Half of that angle. Why is that? Because the angle which an arc subtends at the center is twice that at the radius. So that's how these two are related. So this one here is double of that one. Okay, now, if we turn the question around here, let's say different color. So this is the angle that the arc is subtending at the center, and this is the angle that is subtending at the circumference. So that's 130. If this is 130, okay, what is this going to be?
65.
Okay, so we have angle XYZ is 130. Now hang on a second. We've also got these lines here. What do these lines mean? Anybody got an idea what these lines mean? That these lines mean that these two lines are equal in length. Okay, so we can say now, okay, also now, if this is 130, what about these two angles? These two angles are opposite angles of a cyclic quadrilateral. So that's 130. This angle here will be most definitely 50. If that is 50 and that's half of this one will now be 100. Let's get a rubber and rub this bit off here and make it a bit more clearer. 100. Okay, done. Okay, are we happy with those angles now? So we have to give the angle there's 50 and we're going to say why. So let's put 50 down here. It says give a reason for your answer. So what are you going to say here? So angle XWY, okay, which is the one they wanted to look at. X, okay. Right hand side angle XWZ. XWZ, sorry. Angle XWZ is 50, isn't it?
Is that the top bit, sir?
Yeah, should be Z, sorry. Wrong letter. So angle XWZ is equal to 50. Okay, y is equal to 50. So we say opposite angles of a cyclic quadrilateral. Okay, we run out of space on there. Hang on a second. Quadrilateral. That's why.
Part 2 now.
Part 2 now. Because work out the size of the angle. After we finish this question, we'll have a break, inshallah. Work out the size of the angle OZY. So we know that's 50. We know that's 100. Okay, now what do we know about these two lines? And now remember, okay, remember here that not only are these two equal, but these two lines are also equal, aren't they? Why they're both equal? Because these are radius lines. Okay, so that means that these two angles here will be equal because of the symmetry of the shape. So we have to work out. Is that my phone? Code. Okay, we already said this. We already worked out this angle here is 100. How do we know this is 100? We said that's 130, that's 50, that's 100. We have to explain that in a bit. Okay, now we got to work out this angle here. So the OZY. So I'm going to do this part B up here. Okay, part B. So we're going to say OZY So OZY is equal to 360 because it's quadrilateral minus the angles that we know, minus 100 and minus 130. And because this angle here is equal to the angle there, we have to then divide it by 2 to get our final answer for OZY. Okay. And that should give us an answer of 65 degrees. And what's the reason for that? So we say here, angles of a quadrilateral So that's the understanding for that question. Angles of a quadrilateral. Which quadrilateral were we talking about? Okay, actually we should have put that in really. I'll just slip it in here.
So for that to that only 65 degrees.
Yeah, but we've got to give a lot of explanation now. Quadrilateral. What quadrilateral was it? O X Y Z. So the quadrilateral I'm talking about is O X Y Z. And we put that in brackets. It's supposed to really be in between. When we talk about quadrilateral, we mention the quadrilateral. Add up to 360 degrees. Done. Okay, are we happy with the 65? So the actual answer is 65 degrees, but we need to explain where this 100 came from. Now, where did the 100 come from? So we have to say now. Okay. So angle X O Z is equal to 100. Okay, Y is equal to 100. What is the English for that? So, sorry, the mathematical explanation for that. What do we say? The angle subtended at the center of a circle is twice okay, let's start again here. Is twice the angle subtended at the circumference. Okay, that's why that is 100. Okay, what's next? Angle WXY was WXY. WXY is equal to angle WZY equal opposite angles of a kite as 2 sides. Okay. Ah. Okay. Here comes one last piece of explanation. Okay, I don't know whether we fit it in over here. We're going to make one more statement. Black and red. So we can say angle. What do we say for angle WXY and angle WZY? So these are equal, isn't it? So angles WXY, okay, is equal to angle WZY. Now this shape is called a kite, and it is, what we call it, it is symmetrical, yeah? So let's give an explanation. Okay. Equal, opposite angles of a kite WXYZ.
So what does it mean already?
Radii. That's a radius. So it's plural. That's it. And that will give us a full mark for that. Now it's time for us to have our little break. So the explanation for the last part, part B, that's the answer of 65, but we have to give it also the explanation, blue one and the black one and the red one. So all of these three belong together with part B. Absolutely essential to explain part B, and that will give you 4 marks for part B for making the blue statement, the black statement and the red statement. The green statement is only for part A. I have to write them on top of here because I got no more space in the bottom. Okay, so part B, I'm just going to highlight it all now with the highlighter. So part B answer is all of this. And this one here is part A. And this one here is part B. Okay, now we've done all those questions. Time to stop. Okay, is that the end of the paper? Good. Okay, folks, until next time, inshallah.